Hey everyone, this is Miss Alice. I am here today to help you balance chemical reactions. This is a pretty important skill in the class, so it's important that you can be able to do this. Hopefully I'm going to give you a way to make it a little bit more logical and to work it out mathematically rather than just looking at it and trying to guess the answers. So hopefully it helps. There are a few things that you need to be able to do before you watch this, and that is to count atoms. And so if you don't know what I mean by counting atoms, then go check out the chemical counting video. So let me give you an example. So remember, if we have something like C2H4, it means I have 2 carbon atoms and 4 H atoms. Now the only way I can change my total number of atoms for this compound is to use a coefficient or a big number out in front. So say I were to put a 3 right here. Now that 3 applies to the entire compound, so it acts with a distributive property in math, where 3 times 2 is 6, and 3 times 4 is 12. So now, looking at this compound, I have 6 total carbons, 12 total hydrogens. If I apply it to something like Na3N, I have 3 sodiums and 1 nitrogen. Remember, N is 1 since there is no subscript. Now if I were to put a number in front of this, or a coefficient out in front, like a 5, now I have 15 total NAs and 5 total Ns. So if you're not comfortable with this counting atom thing, then go check out that chemical counting video because it should really help. So let's go ahead and get started with balancing reactions. So I always like to give you a guideline of what to do. So here are steps. If you get stuck, just come and look at this and hopefully it'll help. So first thing, you need to identify the reactants and the products. So remember, in a reaction, my reactants are on the left and my products are on the right. According to the law of conservation of mass and energy, I have to have as many atoms on the left and on the right. They have to equal the same. So if I had 4 hydrogens on the left, you have to end up with 4 hydrogens on the right side or the product side. Okay, so you're going to identify what your reactants and products are. Then you're going to list the elements in the same order on both sides. I'll show you what I mean with this with our examples. Then you're going to count the number of atoms on each side, and starting with the largest difference, or weird things like 2 and 3. You're going to balance the formula using the coefficients out in front. You're going to double check your balance equation by counting the numbers and types of atoms on both sides of the equation. And we'll do this every time we add a coefficient, just to keep us from making careless mistakes or from missing all of the things that need to be balanced. So let's go ahead and do an example. So I'll do some examples and I'll leave you some examples to do yourself. Alright, so let's start balancing. Alright, so if we look at this equation, don't worry about these AQs and Gs and AQ and S right here. They're just talking about the states of matter. It's not going to matter when we balance reactions. So I'm just going to read it without them. So ZnS plus O2 yields ZnO plus S. The first thing I do is I draw a line underneath my arrow, and this kind of breaks up visually the left side and the right side for me, so I don't make careless mistakes. I'm going to go through and write down the elements that I have. So Zn, S, and O, and I write them on the same order, Zn, S, and O. So they're not going to occur in the same order on the right side, but I write them in the same order so I can more easily see if my atoms are balanced. Then I go through and I write down how many I have. So zinc on the left, since there's no subscript, I assume a 1. Same thing for S, there is no subscript, so I assume 1. Oxygen, there's 2. On the right side, there is 1 zinc. On the right side, there's 1 S. On the right side, there's 1 O. So if we look at our equation right now, the only thing that's not balanced is oxygen. So the only way I can balance oxygen is by putting a coefficient out in front of the compound or where oxygen occurs. So oxygen is right here, so I'm going to need to put a coefficient in front of it. When I put a coefficient in front, it's like multiplying. Remember the distributive property. So in order to get 1 to equal 2, I'm going to have to multiply by 2. I'm going to put that coefficient up here. Now I have to look back and check, is there anything else that needs to be multiplied by 2? And the answer is yes, because when you put this coefficient there, it multiplies the O, but it also multiplies the zinc. So I have to come down here and update zinc as well. So now I have 2 zincs on the right, 2 O's on the right. And you might be tempted to just be done here, but remember we have to make sure everything is balanced all the time. So if we go back and double check, we have 1 zinc on the left, 2 on the right. So right there, we're not all balanced, so we have to keep going. So on the left side, I have 1. I need to get it to equal 2, so I'm going to have to multiply by 2. I'm going to put this in the blank where it belongs. I'm on the zinc on the left, so I'm going to find the zinc on the left and put a 2. Then I ask myself again, is anything else when I put that coefficient there get multiplied? And the answer is yes. 2 multiplies the zinc and the S. So I have to multiply the S by 2 as well. So I update my count. So I have 2 zincs and 2 sulfurs. Alright, then I go back and check and see if I'm done. So I have 2 on the left, 2 on the right, 2 S's on the left, 1 S on the right. So now my S's aren't balanced. So the S on the right side is smaller, so that means I need to multiply to equal the left side, so I'll multiply this by 2. Go and find S, which is right here, and I'll put my 2. I ask myself, does anything else get multiplied by 2 when I put that coefficient? The answer is no, because S is just by itself here as an element. So I can finish my updating my count, which is 2, and if I go back and check, now everything is good. You'll notice that oxygen didn't get multiplied by anything, which is okay. So if you get to the end of balancing and an element or a compound didn't need a coefficient, you can either leave it blank or you could write a 1. Either way is correct. Alright, let's move on to the next one. I'm going to go ahead and put a line here. So this says Cu plus AgNO3 yields Ag plus CuNO3 2. Alright, so now we're going to go and list our elements. So we have a Cu and Ag. Now, I want to look at this. This NO3 occurs in the same order over here. NO3, this is the polyatomic ion nitrate. If you have a polyatomic ion, so you have these like series of elements that occur in the same order, we're going to say that's like a single unit. And I'm going to leave these parentheses here just for discussion in a second. And I'm going to go through on the right side and I'm going to list my elements the same. Alright, so on the left side we have 1 Cu, we have 1 Ag. Now on the NO3s, remember I'm treating NO3 as a unit. So if I ask how many NO3s you have, you're not going to say 3 because the 3 is in that compound. So if I'm asking for how many things of NO3 do I have, it would be 1. If I go ahead and do the right side, how many NO3s? I would say 2. If I finish out my atom count, 1 Ag, 1 Cu. Alright, so now on this one, the only thing that's not balanced is my nitrate, or my NO3. So I have to come to the left side and multiply it so I can equal the right, and I'll have to multiply by 2. Again, I put my coefficient out in front of my compound where NO3 exists. Remember, since I'm multiplying on the left side of this line, that's where I'll go put my numbers. Then I ask, when I put that 2, it multiplies the NO3, but is there anything else that needs to be multiplied? The answer is yes, the Ag. So I multiply this by 2. I update my counts. So 2 times 2, or 1 times 2 is 2, so I have 2 Ags, 2 NO3s. So now my silvers aren't good, so I need to come back on the right side, multiply this by 2. I put the coefficient in front of the Ag. I check, is there anything else that needs to be multiplied by 2? When I put that 2 in front of the Ag, the answer is no, because it's just a compound by itself. Alright, and if I go back through, I have 1 Cu on the left, 1 on the right, 2 Ags on the left, 2 on the right, 2 NO3s on the left, 2 on the right. So now I am done. And I can either leave it like this where my Cu and my CuNO3 are blank, or I can put a 1. Again, it doesn't matter, they're both correct. Let's do a couple more. So on this one we have N2 plus H2 yields NH3. Just 2 elements. I'll write down how many I have of each. So I have 2 and 2, 1 and 3. So I said for you guys to start with the biggest difference. And now we have 2 things that are different. So we got to figure out, okay, where am I going to start? So 1 and 2, that's one away from each other. 2 and 3, that's one away from each other. So how do you know where to start? So if you're going to want to start with like the weirdest things. So if we look at H2 and 3, I can't multiply 2 and get 3, and I can't multiply 3 and get 2. So I'm going to have to multiply them both to get their least common, or their lowest common multiple. And that would be 6. So I know I'm going to have to make hydrogen equal to 6, and on the left, and hydrogen on the right to equal 6. Doesn't matter if you start on the left or the right. I'm going to start on the left. So I know I'm going to have to multiply this by 3. I put that in the blank in front of the H. There's nothing else that gets multiplied by 3 because it's just an element by itself. So now I have a total of 6. Then I'm going to come over here. I know my H has to equal 6. I only have 3, so I need to multiply by 2. I put that in the blank. And then I ask, does anything else get multiplied by 2? The answer would be yes. The nitrogen. I update my counts. And now it's all balanced. So 2 and 2, 6 and 6. So I can leave this N2 blank, or I can add a 1. So if you have things like 2 and 3 for the same element, then you're probably going to have to equal 6 and start with that. Same thing, if you had something like 3 and 4, you'd want to equal 12. If you had 3 and 5, you'd want to equal 15. All right, let's do another. So we have Ag2S yields Ag plus S8. So I do my atom count. I have 2 and 1, 1 and 8. If I look through, I know I'm going to be able to multiply 1 and get 2, and I can multiply 1 and get 8. So then I just start with whichever difference is bigger, or where the greatest jump in my atom count. So 1 and 8 is a much bigger difference than 1 and 2. So that means I'm going to come over to the S, and to get 1 to equal 8, I'm going to have to multiply by 8. Put that in my blank up top. And then I ask, do I have to multiply anything else by 8? And the answer is yes. I can't just multiply the S, I also have to multiply the Ag. So now I have 16 and 8 total. And then you're not balanced. Your sulfurs are good, but your silvers aren't. So I have 16 on the left, 1 on the right. So you'll have to multiply this by 16. There's nothing else in there besides Ag, so nothing else needs to be multiplied by 16. I check, everything is balanced. So I can either leave the S8 as a blank, or you can put a 1. Alright, hopefully you're kind of getting the hang of this. Let's do some more examples, then I'll let you do some on your own. Okay, these may look way more difficult, but I promise they're not. As long as you do the same process each time, one is no more difficult than the other. So we have B2Br6 plus HNO3 yields BNO33 plus HBr. So I'm going to write my atoms, B, Br, H. Again, that NO3 we're going to count as a unit. The same order, B, Br, H, NO3. So if we do the left side, B or boron, there are 2. Bromine or Br, there are 6. H, there is 1. NO3, there is 1. Remember, this 3 is with the NO3. It counts as part of it. Then on the right side, I have 1B. I have 1Br. I have 1H. I have 3 NO3s. So if I look through, there isn't going to be anything weird like 2s and 3s or 3s and 4s that are together. I have 1 and 2, 6 and 1, 1 and 1, 1 and 3. So again, I'll start with the biggest difference, which is bromine. So on bromine on the right side, I'll have to multiply by 6. I go and find bromine, which is right here. I put in my 6. I ask myself, does anything else need to be multiplied by 6? And the answer is yes. I can't just multiply Br, but I also multiply H. Then I update my count. So now I have 2 B's, 1 B on the right. 2 BRs on the left, or 6 BRs on the left, 6 on the right. 1 H on the left, 6 on the right. 1 NO3 on the left, 3 on the right. So again, I'll start with my biggest difference again, which is my H. So I have 6 on the right, 1 on the left. So I have to multiply this by 6. I put it as my coefficient. I ask myself, do I need to multiply anything else by 6? And the answer is yes. I have to multiply that NO3. So now I have 6 NO3s. And now I go back and start from the beginning. 2 B's on the left, 1 on the right. 6 BRs on the left, 6 on the right. 6 H's on the left, 6 on the right. So now my bromines and my NO3s are still off. So it doesn't really matter what you start with, but let's start with NO3 since it's the biggest difference, 3 and 6. So in order to make 3 equal to 6, I need to multiply by 2. I put that in the blank. That'll equal my 6 nitrates because 2 times 3 is 6. But I have to check, is anything else in that compound? Does anything else need to be multiplied by 2? And the answer is yes, the boron. And now if I look, everything should be balanced. Boron, 2 on the left, 2 on the right. Bromine, 6 and 6. Hydrogen, 6 on the left, 6 on the right. Nitrate, 6 on the left, 6 on the right. So everything is good. I can either leave this B2, BR6 blank, or you can put a 1. Again, it doesn't matter. One's not wrong, one's not right. Typically we don't write 1s in chemistry, but it's not wrong. Then last one we'll do together for practice. VF5 plus HI yields HF plus V2 I10. Alright, so if we do our atom count, V is 1, F is 5, H is 1, I is 1. On the right side, V is 2, F is 1, H is 1, I is 10. So if I go through, there's nothing weird. I can multiply 1 and get 2. I can multiply 1 and get 5. 1 and 1 are the same. I can multiply 1 and get 10. So nothing weird, so I just start with the biggest difference, which is my I. And to get 1 to equal 10, I'll have to multiply by 10. When I put a 10 in that blank, I have to also multiply my H because it's also in that compound. So now I'll update my atom count. So now I have 1 V on the left, 2 on the right. 5 F's on the left, 1 on the right. 10 H's, 1 on the right. 10 I's on the left, 10 on the right. So again, I'll start with the biggest difference, which is hydrogen. I need to multiply this by 10. I put that in my coefficient out in front of the compound. I check, does anything else need to be multiplied by 10? The answer is yes, the fluorine, or the F. So now I have 10 F's and 10 H's on the right. On the right, or the left side, I have 5 F's, so that's not good. I have 1 V and 2 V's, so I need to do something over here. I'll start with the 5. I need to multiply it by 2. Put it in the blank up top. I have to multiply the F by 2 now, but I also have to multiply the V by 2 now, because they're in the same compound. And just, oh, that's not right. And just like that, everything is balanced. So 2 and 2, 10 and 10, 10 and 10, 10 and 10. So we're good. So I can either leave this blank or I can put a 1. Okay. Let me show you another quick way of just double checking. And that's actually just going through and doing an atom count. So I'll do this atom by atom and show you. So I'll start with V. So for V, 2 times 1 is 2. Over here on the right side, 1 times 2 is 2, so my V's are balanced. If I come back and do my F's, 2 times 5 is 10. 10 times 1 is 10, so those are balanced. Moving on to my H's. 10 times 1 is 10. 10 times 1 is 10, so my H's are balanced. And then my I's, 10 times 1 is 10. 1 times 10 is 10. So I still get all the same numbers. So that's another way you can go through and just double check to make sure you have the right responses. Okay, so why don't you get a sheet of paper and a pencil and try these. So I want you to try these 3 on the paper. Whenever you're done with the first one, I want you to check it. So I'm going to assume that you want to make sure you understand and not just listen to me. So whenever you're working a problem, hit pause. Whenever you play a problem or want to see it work out, hit play. So if you want to work out the first one, go ahead and hit pause now and then hit play when you want to check. So hit pause now. Okay, so I'm going to assume that you've pressed play. Let's go ahead and balance this one. You should have gotten a 1, a 3, and a 2. If you need it worked out, you had BR2, F2, BR1, F3. Since the 2 and the 3's are weird, we'd have to multiply this by 2. When you do that, it goes in the coefficient that multiplies this by 2. And we have to come over and multiply this by 3. Alright, so go ahead and hit pause again and press play when you're ready to do the next one. Alright, so this one hopefully was pretty easy. You had 2 P's, 1 P, 5 oxygens, 2 oxygens. So the oxygens were the ones that were kind of weird because you can't multiply 2 and get 5 or 5 and get 2, so you had to make them each equal 10. Which, I mean, this is a 2 and that would be a 5. And then we have to fix our phosphorus, which is 2 and 2, which would equal 4. So if you wanted to see this worked out long ways, PO, PO, 2, 5, 1, 2. These are the ones that are the weirdest. So we'd have to multiply this by 5 to get 10. We'd have to multiply this by 2 to get 10. And since this is in the same compound, this gets multiplied. And then we'd save this one for the end. So that's why I say I always start with the biggest differences or the weirdest, because you could have, just done 1 times 2 at the beginning to multiply phosphorus. That wasn't your biggest or your weirdest difference. So start with the biggest or the weirdest. And then last one, multiply this last one on the page. Hit pause, hit play when you're ready. Alright, really you can just look at this one by inspection. You have 1K and 1K, 1 mg, 1 mg, 1 br, 1 br. So this is actually already balanced. You can leave them all blank or you can put all ones in. Sometimes that'll happen. This wasn't there to trick you. Alright, and then I want you to try these 2 as well. I do want you to notice that OH occurs on both sides. PO4 occurs on both sides. And then on the second one, SO4 is on both sides. PO4 is on both sides. Remember, treat those like units. So go ahead and try this first one. When you're done, hit play. So hit pause now. Alright, hopefully you've worked this out. I'm going to do this one long ways. I'm not just going to give you the answer. It's important that you write these in the same order. Alright, so we got 3, and did you get 1 phosphate, or 1 PO4? 1 Na, 1 OH, 1 H, 1 PO4, 3 NAs, 1 OH. So on here, the only thing that's different is Na and H. They're both the same difference, so it doesn't matter where you start. I'm going to start with the H's. So you multiply this by 3. I go and find the H on the right. Put it out in front. I can't multiply just the H. I also have to multiply OH, so I come down here. Then I update my count. So my H's are now good. They're both at 3. Phosphate's still good at 1. My sodiums are off, and my hydroxides are off. So again, it doesn't matter which one you multiply first. So I multiply this by 3. When I put that in the blank up top, then I can't just multiply the Na. I got to also multiply the OH because it's in the same compound, and that's what a coefficient does. And when I do that, everything is balanced. So I'm just going to leave the others blank, but remember, you can put 1s there if you want. So go ahead and try the next example. Hit pause, hit play when you're ready. Alright, so hopefully you've hit play. Same thing, let's work this out. Ca, PO4, H, SO4, Ca, PO4, H, SO4. Again, it's really important that you write them in the same order. So 3, 2, 2, 1. 1, 1, 3, 1. Okay, so let's go through and balance. So 3 and 1, 2 and 1, 2 and 3. This looks weird. So I can't multiply 2 and get 3. I can't multiply 3 and get 2. So I know these are going to have to just be multiplied to equal their least common multiple, which is 6. So I'll have to multiply this by 3 and this by 2. So I'm actually finish this out on the left. So when I put a 3 here, I can't just multiply the H. I got to also multiply the SO4, which gives me a total of 6 H's and 3 SO4s. If I go back and fix the right hydrogen, I need to multiply by 2, but I can't just multiply the H by 2. I also got to do the PO4. Now I have 2 and 6. So now I have 3 calciums, 1 calcium, 2 phosphates, so that's good. 3 sulfates, 1 sulfate. So I need to have more calciums and sulfates on the left, so I got to balance with it on the right. So I multiply by 3. When I put a 3 there, it goes to the Ca and the SO4, so I have to multiply the Ca and the SO4. So this one you should have 1, 3, 3, 2, or just a blank 3, 3, 2. And you can put the 1 there, or you can leave it blank. It doesn't matter. It's the same thing. Alright, so those are the majority of the ones you're going to balance. I just have one more to talk about. And that is if our combustion reactions. You're not going to have to balance these often, but I do want to show you. It's going to work the same way. We're going to write our elements. The only difference is that you have oxygen here and here. So we're not going to write them as just one occurrence. We're going to write them as together. So let me show you how to do this. So C, we have 1, H, we have 4, O, we have 2. On this side, C, we have 1, H, we have 2. O's, if we look, we have 2 here and 1 here. So that's how I'm going to write them. 2 plus 1. I'm not going to make them equal 3 because it's going to mess you up when you start putting coefficients. So when you do combustion, you're going to balance always carbon and then hydrogen, and then you'll save oxygen for the end. So let's balance our carbon. I have 1 on the left, 1 on the right, so nothing needs to be done. Then I move to my hydrogens. 4 on the left, 2 on the right, so this gets multiplied by 2. And then I check, just like always, is there anything else going to get multiplied by 2? And the answer is yes. I can't just multiply the H, have to multiply the O. So when you come down to oxygen, you have 2 plus 1. You didn't multiply that one, you only multiplied this one. So then you'll multiply only the 1. So 1 times 2 is 2. And then everything else is good. My carbons are good, my hydrogens are good. So now I can finally add up my oxygens. So 2 plus 2 equals 4. And to get 2 to equal 4, I multiply by 2. There's nothing else in that compound, so I'm done. Let's work another. So C3, CO2 yields CO2 plus H2O. Remember, combustion is always going to have CO2 and H2O as the products. So 3, 8, 2, 1, 2, 2 plus 1. Alright, so I balance my carbons first. Doesn't matter what the biggest difference is, always do carbon first. I'm going to do times 3. When I put that 3 there, I multiply the C, but I also multiply the 2 oxygens. So I come down to the 2 oxygens and I multiply by 3. 2 times 3 is 6. Alright, so now I balance my hydrogens. I have 8 and 2. I need to multiply this by 4. So 4 times 2 is 8. I also have to multiply this oxygen. 4 times 1 is 4. Since my carbons and hydrogens are balanced, I can come back and do my oxygens. I have 2 on the left. I have 6 plus 4, which equals 10. To get 2 to equal to 10, I multiply by 5. And now I'm done. Let me show you when it doesn't work out so perfectly with the oxygens. So sometimes when you add up your oxygens, you won't get an even number, which means you can't just divide by 2 to multiply your oxygens. You'll have to do something else. So let me show you. It's not too difficult. CHO, CHO. 6, 14, 2. 1, 2, 2 plus 1. Alright, so we would start this the same. I'm not going to show all the math, but we would do this. We would put a 6 here to multiply our carbons. For the hydrogens, we have 2 and 4, so I'd have to put a 7. If I update my oxygens, I would have 6 times 2, which is 12, 7 times 1, which is 7. 12 plus 7 is 19. However, I can't multiply 2 and get 19. So if you get to this situation and you're like, wait, I can't multiply 2 and get that number, then you're just going to come back. You're going to kind of start over. And you're just going to put a 2 on your beginning compound. So this equals 12, this equals 28. And now you'll start balancing carbon and hydrogen again. And this should give you an even result. So to get 12 carbons, I'd have to put a 12 here. This also multiplies my 2 oxygens. So now it's 24. Plus 1. I balance my H's. I have 28 on the left, 2 on the right. So I need 14 here to equal 28. But I can't multiply just the H. Got to also multiply the O. So this 1 becomes 14. And then 24 plus 14 is 38, which is divisible by 2. So I have to think about 2 times what equals 38. The answer is 19. So put a 19 up in that blank. And that right there is pretty much the hardest thing that you would have to balance in this class. And that, I mean, it's pretty advanced. So hopefully this helps you with balancing. Remember, these combustions, if they're kind of throwing you off and you are kind of panicking, these are not the ones that you're going to have. The majority of the ones you'll have will be like the ones we did on the other slides where I let you practice. So hopefully this helps. Feel free to come back to this and watch multiple times and try the practice on your own. If you need help, just let me know. I'll be happy to do that. I know this was a bit of a longer video, but hopefully it really has helped you with balancing reactions. So thank you and have a great day.